Hello everyone, thank you for joining my tutorials. Today we'll learn how to prepare land use land cover map using this support vector machine classifier. So what is actually this support machine classifier that we'll see? Actually the SVM means support vector machine classifier is a powerful supervised classification method. Okay, it is a well suited for segmented raster input but can also handle standard imagery. It is a classification method commonly used in research community. The advantages of this SVM over a maximum likelihood classification is that the SVM classifier need much fewer sample and does not require the samples to be normally distributed, and it is less susceptible to noise, correlated bands, and unbalanced number or size training sites within each class. So this is the benefit of SVM over this maximum likelihood classification. So today we'll see how we can able to prepare the land use land cover classification using this support vector machine classifiers. So we have a data set that is a Landsat, and this Landsat 8 data set you can download from the USGS Earth Explorer. I have already shown in previous videos that also you can able to see, and I will add a band here up to 1 to 7 bands I will add here. So band 1, band 2, then band 3, okay, band 4, band 5, 6, and this 7. I have added this 7 band here because all this 7 band is having a same spatial resolution. If we'll see here, all the band is having mostly 30 meter spatial resolution. So for the band composite, we require all the bands should have a spatial resolution equal like the 30 meter, and also it is having a same spatial extent. So after that we can go for the classification technique. So in the R toolbox, here is the R toolbox. In the R toolbox for the band composite, we'll go to the data management tool. The data management tool, there is a raster. In the raster, there is a raster processing. In the raster processing, there is a composite band. So we need to add this band one by one. So sequentially, so take band 1 first, then band 2, band 3, band 4. Like this, we need to add all our bands sequentially. So band 2, band 3, band 4, band 5, band 6, and band 7. After that, just we need to save this composite in which folder we are working. So the D drive, I have one folder. In that I will create a new folder, SVM classification. In that I will save as this is a composite band .tif. Click on save and just click on OK. So I'm saving this in one folder. So what we are doing here, we are compositing band. All these band are different bands. To create a false color composite, we need to create a band composite. So after creating a band composite, we can able to see where is the vegetation, where is the water body. Using the different band combination, we can identify the things on a satellite imagery. So our band composite is ready here. Now we can able to check here. So let's go to symbology. So I will select a false color composite, 5, 4, 3, apply, and OK. So now these things we don't require now, so we can remove from here. And now we can able to identify the things here. This is the water body, so we'll take some samples for the water body. So this one is the agricultural area. This is the mostly our built up area is there. Then this area is having some forest area. So like that we can able to create some training samples, and as we are creating some training samples, after that whatever the sample will provide, suppose we'll take some samples here for the built up, some samples will take for the built up. So wherever there will be the built up, after that doing the algorithm, it will show us a built up here. So for that, we need to create a training sample first. We need to provide a training first. So that is a supervised technique that we are going to use here. So I will take these training samples here. The classification tool, you can add from here customization. Here in the extension, we need to select this spatial analytics. When we'll select the spatial analytics, this classification tool will activate. Or from right click here, you can also from right click here, we can add this image classification tool. After adding this image classification tool, from here we can from these training samples, we just need to take some training samples here. So just add a polygon here. So I will take some samples for this built up area. Or if you are facing problem while identifying the things on the satellite imagery, what we can able to do, we can add a base map here. So we can add a base map here. So after adding a base map, we can able to see it is built up there or not. So if it is built up there, we can provide this class, and after that we can group all the samples, and after that we can provide a name to it. So we can able to check here. So see, this is the built up area, and let me take more samples for this built up. So let them group together, and I will provide name as a built up, and I will provide a red color to it. So similar way, I will take a sample for the water body. So this is the water body. Wherever there is a water body, I will take some samples. Like that, we need to take a samples for water body. So let's select this from first to last, whatever there, by using the shift key, and just merge it and provide here is a water bodies. I will provide a blue color to it. After that, we will add vegetation or forest area and agricultural area. So this area is mostly forested area. So now we can able to see here. So we'll provide vegetation or forest, you can provide here. So just I will merge it. I will provide a forest. I will provide a green color here. After that, we'll provide this agricultural area. So now you can able to see here, this area is having an agricultural area. So just take some samples for the agriculture area. So just I will group them together, and I will provide as a like that. We can add a number of classes here, like a barren land. Then also if there is a mining area is there or any area is there. So like that, we can add number of classes here. So like this, we need to check what are the classes are there. We can add more classes here, but for being example here, I'm taking only these 4 classes. And after that, we just need to go again, we need to go the spatial analysis tool. In the spatial analysis tool, there is a segmentation and classification. In the segmentation and classification, this we need to use here. But before that, we need to save these training samples. We just need to click here as a save training samples. So in the SVM, I will save training sample. After saving this, just click on this segmentation and classification. There is a train support vector machine. So just input raster images over this band composite. Then input training sample feature, which we just saved, this training samples that we need to add. So this I have saved in video lecture. This is SVM. So this training samples which we have saved, add here. Then output classified definition file means where we need to save this SVM file. So I will save in the same folder. I will provide a name SVM training. Just click on save and just click on OK. Now we are creating this train support vector classifier. So this train support vector classifier is now ready. So after that, we just need to click on classifier raster, and here in. So before saving training samples, we just need to click here as a save training samples. So in the SVM, I will save training sample. After saving this, just click on this segmentation and classification. There is a train support vector machine. So just input raster images over this band composite. Then input training sample feature, which we just saved, this training samples that we need to add. So this I have saved in video lecture. This is SVM. So this training samples which we have saved, add here. Then output classified definition file means where we need to save this SVM file. So I will save in the same folder. I will provide a name SVM training. Just click on save and just click on OK. Now we are creating this train support vector classifier. So this train support vector classifier is now ready. So after that, we just need to click on classifier raster, and here input raster, I will provide this same as our this composite band. After that, input classifier definition file, which we just save as a SVM file. This SVM file we need to add, that is a .ecd format should be there, and output raster, that is a SVM LULC .tif, and just click on OK. So our final classification map will be prepared. So finally, our SVM map is prepared. So now here if you'll see, here is the built up area below. So we can able to see the built up area. Then this yellow color is for the agricultural land. Where there is agricultural land, we can able to see agricultural land. Where there is a forest, it is showing a forest. And where there is a water body, it is showing a water body accurately. If you will get some mismatch, if you'll get this mismatch here, okay, we are getting, now you can able to see here somewhere there is a no built up area, okay, but it is showing us a built up area. Then what we need to do, we again need to add some samples here. We need to define this area again. Okay, so here it is showing built up area. So what we need to do, again we need to take some samples here, okay, and we need to provide, we need to merge this with our forest area. Okay, so this is our forest, so we just need to merge with it forest. And again we can save these samples. Again we need to save these training samples. After saving this, just go to again train support vector classifier, and after going to support vector classifier, you again follow the same process. Then this area, whatever the area are there which is showing in built up, now again it will convert to your forest area, because this pixel, it conclude as a built up area, but actually this is not built up area. So we just need to take samples, and again we need to, after adding this, after merging this, we can again go to the same process, and after that this change, this area will change to our forest area. So like this we need to do this again and again, this classification, then our accuracy will be more. And we can add more classification here. After that there will be more accuracy. So this way you can able to prepare this SVM classification very easily.